Okay, so today we are looking at graphing square root functions. Our goal is to be able to construct a graph of a square root function. And here we can see the parent function for the square root function given here. So this is the parent function. You want to be familiar with some points along this function. So it starts at 0, 0. This is the most important point. This is the vertex. And then it goes through 1, 1. And look at this point, it's going to go through here, 4, 2. If you think about your square numbers, our next one's going to be here at 9, 3. These are useful points. We need to sketch the function root x minus 3. Now, this is a transformation. What transformation do we have here? What transformation do we have here? Don't shout out. What transformation? And don't say gibberish either, that's not good.
A horizontal transformation, 3 to the right.
We have a horizontal translation. This is a horizontal translation. If you think about the function, this is y equals f of x in general form. So this is y equals f of x minus 3. Horizontal translation right 3 units. So in order to draw this one, we need to translate the function 3 units to the right. Always start with a vertex. The vertex with the translations is not affected at all by any dilations. Because it goes through 0, 0, no dilation is going to affect this one. It's just going to move it around with the translations. So we need to go 3 units to the right. It's going to start here. This point is going to get moved 3 units to the right. I often think of this point as 1 across, 1 up. From there, 1 across, 1 up. This one is 4 across and 2 up. So we need to go 4 across and 2 up. We're going to go through here. Okay, it's going to look like this. Okay, so we're going to sketch this function. What transformations do we have on this one? Hands up, let's have hands up. Discuss brief, take a minute to think about it, discuss with the person next to you, and then let's have hands up. The logic on the inside is always backwards. Alright, so what transformations do we have?
You have a horizontal translation, 1 unit left.
Horizontal translation, 1 unit left, yes. What else?
A vertical translation, 3 units down.
And a vertical translation, 3 units down. So what will be the coordinates of the vertex of the curve?
-1, -3.
Yeah. So it's going to go through -1, -3. This point is always 1 across, 1 up. So it's there. This point is always 4 across and 2 up. So 1, 2, 3, 4 across, 1, 2 up. This point here is 9 across and 3 up. So 9 across from there would be 8, and then we need to go 3 up. Okay.
How many points should we usually graph?
2 or 3.
Okay.
So vertex plus 2 is 3.
It depends on the space. So for instance, on this one, I didn't bother trying to do the 9, 3 because it's off the ground. Yeah. So just some useful points that help you get it. All right. Discuss with the person next to you, what are the transformations here? Discuss with the person next to you. You're not going to get answers.
It's horizontal.
Oh yeah, one of the functions is minus 1 over
So it's 3, 0. It's negative 3, 0. And it's negative 0.
Okay, what are our transformations that we have this time? What are our transformations that we have this time? We can take this here.
Horizontal translation to the left 3 times.
Horizontal
3 units.
translation left 3 units. And
Then a vertical dilation of
vertical dilation
by factor of 2.
by factor of 2. What does that mean?
It's a stretch.
What, it's a stretch?
Yeah.
But what does a vertical dilation by factor 2 mean?
You
I mean,
multiply.
it's like stretched by a scale factor of 2.
What? So what, how does the
So
function's
wait,
coordinates
Multiply
change?
So you multiply the vertical, multiply by 2.
We multiply the y values by 2, it does nothing to the x values.
This one was the horizontal.
This one does nothing to the x values. This one, the horizontal translation, moves all of that value, all of the x values 3 units left. So we move all the x values 3 units left. We're going to be here, we're going to be here, we're going to be 1, 2, 3, we're going to be here, and then from 9, 1, 2, 3. So this is our translation. These dots are our translation left 3 units. And then to dilate it, we double the y values. So we're going to go through here. That's going to be at 2 instead of, this one's going to be at 4. This one's going to be up there. So, well, okay, have a go at this question. I want you to take the function there and rewrite it in the form given. Rewrite it in the form given and then make a sketch.
First find the vertex.
You know how the quadratics has
Find the vertex.
Alright, so what would the vertical translation of this function be?
a vertical transition of 1 unit down.
1 unit down. What would be the horizontal translation?
2 right.
Would it be 2 right or 8 right?
2 right.
Let's have a look. Let's have a look. So we've got the function y equals 4x minus 8 minus 1. This can be rewritten as root 4 bracket x minus 2. And it's here at this point we can see that we have a horizontal translation right by 2 units. And this one gives us a horizontal dilation of 1 over 4.
Oh.
This is a horizontal dilation by 1 over 4. Horizontal compress.
Don't you think
This is a horizontal compress. Now, we can rewrite this function to be 2 root x minus 2 minus 1. What we have now is we still have the horizontal translation right by 2 units, but the horizontal dilation by 1 over 4 has become a vertical dilation by 2. It's a stretch. Here we have a horizontal compress. Here we have a vertical stretch. They create the same effect. They create the same effect. So when it comes to sketching this one, we need to make a sketch. What's the vertex of the root function?
2 minus 1.
Negative 1.
So it's going to go through here at 2 comma negative 1. And then our next point, instead of being 1 comma 1, it would go across
3
to
comma
3, 0, wouldn't it?
Or 3, 1.
It would go to 3, 0. And
Yeah.
then instead of going 1 up, we would go 2 up. So it would be here at 3, 1. And our graph is going to look like this. So with a sketch, without coordinate axes and graphs and things to draw on, we just need to do a symbolic representation of how the function looks and plot 2 points and label them. This is how we would do a sketch of this. Maybe I wouldn't have the 3, 1 right there. Let's just do this like that. Our graph is going to look like this, and it's going to go through 3, 1. Then we show with these 2 points our understanding of the 3 transformations that are applied to this function.
What was? Oh, I was gonna say with all functions, is it like the same rule, like the transformation is all the same?
Yeah. What we're starting to see is a very generalized form. So what is this?
It kind of looks like the great
If we have y equals f of x is equal to root x, then we have y is equal to, and we've got 2 different ones. We've got 2 times f of x minus 2 minus 1. So we can see here in general form, it doesn't matter what the function is, we have the same transformations that get applied. This in every function, it is not true that this is equivalent to this. So these are not true for all functions. This is only true for the square root function that we get this relationship. We get a similar bit. It doubles it squares in the opposite direction with the parabola, with the parent function x squared. This is absolutely not true when it comes to trigonometric functions. They don't do this. They're the only one. They're the first one that doesn't do that. But for instance, the ones we've seen so far, the absolute function, the quadratic function, this is the root function, and we've looked at a bit with rational functions. With all of those functions, a dilation, horizontal dilation becomes a vertical dilation. Yeah, the compression becomes a stretch. But this isn't true in all cases, it is true in this one. Questions?
So I don't know if I'm just dumb, but isn't the vertex -1, 2? I don't know if I'm just...
Oh, because he's saying inverse.
What are you saying?
I think he's looking at the inverse, like, you know
That's
how
what we did last time, bro. Inside it was we move it.
Yeah, but that's not the inverse. We write the function of the inverse function.
This is correct.
Yeah.
We are correct. Everybody else agrees with me, yeah?
Yeah.
I think you're outnumbered. Let's have a look. Find the domain and range of this function.
Let's do it.
Find the domain and range of this function.
I'll kill you, bro.
Okay, so let's talk a little bit about reflections. So if we take our standard function like this one, this is y equals f of x, our standard root function, looks like this. We can get 2 types of reflections. We can have a vertical reflection, which would look like this, and this is y equals minus f of x. Or we can get a horizontal reflection.
So I think it was minus x.
This is y equals f of minus x. So if the negative's on the outside, we get a vertical reflection in the x-axis. If the negative sign is inside the bracket, we get a horizontal reflection in the y-axis. So reflect in x-axis.
Sure.
Let me just write this, reflection in y-axis.
You know how like in our first first unit, you had to like prove even and odd. Do you have to do that for these?
Proving even and odd.
Like even and odd functions. Like you
These
know how
can't be even and odd.
yeah, okay.
Okay. What is the domain of this function? The domain is going to be x is greater or equal to 0. Here it's still going to be x is greater or equal to 0. And here it's going to be x is less than or equal to 0. So the domain goes away from the vertex point in one direction or other, depending whether it's going up or down and so on. So with the graph that we've got here, what is the domain going to be? The domain is going to start at x. Where's the vertex of this?
2, 1.
This one's going to have its vertex at 2, 1. So the domain of this one is going to be coming away from that x value in which direction?
Yeah, I'm
Negative.
So the domain will be x is less than or equal to 2. What will the range be?
I have a question.
Mister, don't you have to go like in order? Like,
No.
I have a question. For the
What will the range be?
Less than or equal to 1.
No.
Greater than.
Look, this would be less than or equal to when we reflected in the x-axis, but when we, in the original or in the, when we want it reflected in the y-axis, then we're going to be going upwards. We're going to be going upwards. So this one is going to be y is greater than or equal to 1. Only this one here makes it go down. When we reflect in the x-axis, then it would be less than, otherwise we haven't gone in that direction.
I thought we were right.
Questions? I know.
Yes, the reflection. If we do a reflection over the x and the y, would it be called a reflection over the origin or just an x and a y? Exact question, bro.
Don't know, it would be a reflection. I would just write a reflection in x and y.
but Mister, isn't it with the like other form, like vertex form? Wouldn't that we have to go like inside the brackets, then the outside, and then the plus 1?
Yeah, but that question is relating to this concept here. When we wanted to know what the horizontal translation is, we have to have the bracket here, and there is an order to it. Now, in this one, it's already factored for us into the standard form, so we can see the transformations in the correct order. We have horizontal translation first, then we have horizontal dilation and reflection, they come next at the same order. At this point there is no vertical dilation, it's 1, and then the last one with the vertical translation, the plus 1.
Oh, so you just...
Is this wouldn't there also be a horizontal compression?
There is, we have, but that's not going to affect the domain and range. The domain and range come away from the vertex point, and then that doesn't matter. It affects us when it comes to our sketching. So when we want to do our sketch now, it is going to cause us some issues. So where is the vertex of this one? It says 2, 1. So it's going to go through here at 2, 1. Which direction are we going to go in? Towards positive infinity or negative infinity? In the x-axis.
Negative infinity.
And in the y-axis? So this function, we can say that the limit as x goes towards negative infinity of g of x is going to equal what?
Negative?
Are we going up or down?
Up. So it's infinity.
Up.
Okay.
Our graph is going to look like this. Our graph is going to look like this. So as we go towards negative infinity, it's going to keep rising. Can we put another point on now?
Yeah.
No, we're reflecting direction.
We need one more
Instead of going
point.
this way now.
I know. We need one more point to show our understanding of how the point that's normally 1 across and 1 up, if we go 1 across and 1 up, we would go in this direction. It would be at 1, 2. Now this point is going to go where? This point is going to go where? This is without the half. Now this half creates what type of dilation? Horizontal dilation.
Compression. Oh, yeah, dilation.
And a compression by.
Half.
So what will happen to will it be the x value or the y value that changes?
X.
The x value. What will it become?
0. If you multiply by negative 1/2, or 1/2.
So
0.5.
instead of being -1 in this direction,
0.5 to that.
it will be -1/2 in this direction.
So 1.5.
No.
No, minus a half.
You multiply by
Then what's the moving?
I swear we used to multiply.
No, because you
No, it's 1.5.
No,
when did it be multiplication?
No, it's not 1 because it was 1.
So is this half multiplied by 1?
Because it's
What's happening now?
So is it half multiplied?
All right. So what we see is we're a little bit wrong here on this one. We're a little bit wrong here. This is a horizontal dilation. But what is the factor of the dilation? It's not a half, is it?
It's 2.
It's 2.
Because I told you, so why isn't that ever one all the houses? So what?
How is it 2?
Yeah, how would you know
We used to
It's always the dilation is inside of the horizontal dilation is always 1 over this value.
So it's always the opposite.
It's always that number there.
Mm.
So it's 1 over 1/2.
But what if you take it out?
What you just
So instead of going 1 back, we need to go 2 back. So instead of going to, we would normally be here at 1, 2. We need to go 2 back, so it's going to be here at 0, 2. When I'm recording a video, can you guys try and shut up? Alright. Are we good for this one?
Yeah.
So, normally, we go 1 across, 1 up. 1 across, 1 up. So here on this one, instead of going 1 across, 1 up, we go backwards, -2, 1 up. Because we have a horizontal dilation by factor of half. Sorry, horizontal dilation factor 2. I keep getting it wrong. Horizontal dilation factor 2. Horizontal dilation factor 2. Any questions?
What if the half that was a vertical dilation? Would it be considered a compression or a stretch? Because it's not in the roof.
So the dilation is always the denominator?
This is vertical dilation factor 2. This is horizontal dilation factor 2. What's this? Vertical or horizontal?
Horizontal.
Horizontal dilation,
By two.
By
By two or
Factor.
three. By 2 or 3.
2 over 3.
So you just flip it, even if it's outside.
Inside.
No, not if it's outside.
That's what my
Inside.
question.
Horizontal.
Never if it's
Inside.
outside, only if it's inside. Remember, with the transformations, whether we're going left or right, up and down, inside, the logic's always sort of backwards.
Yeah.
Yeah.
Plus means left. Instead of
Is
outside, plus means up, minus means down. Multiplying by 2 means stretch, multiplying by half means compress. Inside, your logic's all backwards. So instead of plus being to the right, it's to the left. Instead of multiplying by 2, stretching it, it's halving it.
so, if it was, for example, a equals half, and then it's root x minus 3, and then outside it's plus 2, it would be compression.
What, can you tell me the function then?
Yeah.
Y
half.
equals
Y equals
a half.
I just made up anything. Root x minus 3 plus 2 outside.
Okay.
So
We have on this one a vertical translation up by 2 units, a horizontal translation
right.
right by 3 units, and a vertical compression factor half, or vertical dilation factor half.
Okay.
Okay, we got it clear?
So the horizontal dilation is a reciprocal of the,
Write a function that matches the graph using the indicated transformation format. Okay, so let's identify the transformations we have here. What are the transformations in this graph? So the first thing we need to look at is, where is the vertex? What are the coordinates of the vertex?
1, negative
Negative
1, negative
1 comma negative 2.
2. Yeah.
This is the coordinate of the vertex. So this tells us, what are the transformations this tells us?
That has a translation down by 2 units.
Vertical translation down by 2 units.
And translation, horizontal translation to the right by 1.
Horizontal translation right by 1 unit. Next up, we can see that the domain is x is less than or equal to 1. What does that tell us?
It's reflection over y.
Yeah.
It's a reflection over the y-axis. And then lastly, we need to sort of look at this here, in this direction. We've gone 1 up and back 1. So what does that tell us about the horizontal dilation?
Oh, we're reading it wrong.
What does this tell us about the horizontal dilation?
It's negative.
Well, that's the
There's no-
reflection.
It's 1.
It's 1.
And
It's
I'm
1.
reading it wrong. I'm reading it wrong.
So
So this is not right? I mean, most of this right.
we have vertical translation down 2. Horizontal translation right by 1. This tells us h equals 1.
So there's no scale factor. It stays the same.
Domain is x is less than or equal to 1. This is a reflection in
Be quiet.
y-axis. So b is less than 0. And then we can see that we don't have any change to this -1 + 1 pattern, which means we don't have any horizontal, no horizontal.
Or vertical.
Yeah, we can see on the outside we're not looking at a vertical, so no horizontal dilation, which implies that the absolute value of B is 1. So we get y, g of x, g of x is equal to minus 1 bracket x, we have minus 1 close bracket minus 2.
Or
Why is it minus, not 1?
because that you reflect over it. And reflect the
The domain changes, so x is less than
Okay.
x.
So it doesn't have anything to do with the actual like dilation. It's just
There isn't. What?
Have a go at this one. Alright. So what have we got? We've got, where is our vertex? What's the coordinates of the vertex? Negative 2, negative 1. What's the value of h?
2.
What's the value of k? Here, we do this one in red. Here, we go 1 across, oh, we can get red.
1 across and 3 up.
1 across and 3 up. 1 across and 3 up. So what's the value of A?
3.
3. Oh, because it's outside, yeah.
Do we have any reflections?
No.
No, we don't.
No reflections.
But sir, if the A was inside, it would be 1 over 3, right?
It wouldn't be A then, it would be B.
Oh,
And
yeah,
yes,
yeah.
and it
No, that's fine.
wouldn't be, it would be,
1 over 2.
no, it would be 1 over root of 3.
Oh, because it's in the square root.
Okay, so let's take Isla's question. Isla wants to move the 3 inside the bracket. What would the number be inside the bracket?
Isn't it plus 2 or something? Yeah.
No,
1.
because the format is given as x minus h.
Yeah.
Yeah, but it's
Oh,
plus
yes,
2.
it is though.
Because it's a negative.
It's on negative side.
So negative 2, negative 1.
It's negative 2, negative 1. H equals negative 2.
Oh yeah, because in this format, h and k are exactly the values of the
Yeah.
Or exactly.
It should be plus, yeah.
Alright, let's move that 3 inside. How can we move the 3 inside?
Would it be over squares?
1 over 3.
Well,
3 squares.
we need to put the 3.
I told you it was 3 squares.
Oh.
Do we still have a 3 on the outside?
Yes.
So what is 1
now,
over 9?
so now we get root 9.
Oh, what is 9?
So now if we bring it in,
Root 9, you know root 9?
Yeah, watch 1 over 9.
Just factor it. That's it.
Do we need to do that?
no, the question didn't ask for it.
Mr.
But
Putting the 3 in.
we had a pondering. What would happen? How would it look if we bring it in? It's useful information to sort of see. What type of dilation? What type of dilation is this? We have a horizontal compression factor 1 over 9. Or horizontal dilation 1 over 9.
Can you just say dilation?
Sorry. Can we try and focus, please, guys? we have a horizontal dilation factor 1/9 is equivalent to a vertical dilation factor 3.
You have to specify whether it's a stretch or a compression, or can you just say dilation?
As long as you get your factor right in the dilation, that's fine. Alright,
Yeah, obviously.
last question.
Yes.
Have a go at graphing this one. Identify the transformations first.
Okay, so there's reflection.
Okay, so what are the so let's rearrange this. This is going to be 1.5 square root minus x minus 5 plus 2. What's the coordinates of the vertex going to be?
5, 2.
5, comma 2. It's going to go through here. Going to go through here. What's the domain of the function going to be?
The domain of the function is going to be x is less than or equal to 5.
Perfect. So that means the graph's going up in this direction. What's the range of the function going to be?
The range of the function is going to be x is less than
No, f max.
sorry,
Y is less than or
greater than or equal to 2.
Because if you consider.
We'll go in that way. So, normally we go 1 back, 1 up. This time we're going to go 1 back, 1.5 up.
Oh, that's been
Normally we would go 4 back, 2 up. This time we go 4 back, 3 up.
Okay.
So, our graph, let's put our coordinates in. We've got 5, comma 2. We've got 4, comma 3.5. And we've got 1, comma 5. This has gone 1, 2, 3, 4 back, 3 up. This is a good point to draw. Instead of the 1, comma 1, 1, the 1 back, 1 up. It's a bit trickier to draw, but the 4 back, 2 up is easier to draw because 2 times 1.5 is 3.
How many types of functions will we learn this year? We did 3, right?
That's a strange question. Have a go at the exit ticket.